Is it working? Can you hear me? Good. Up at the back, can you hear me okay? Can you understand me okay? Okay. I try my best English, and I've tried to speak slow, okay? Well, continuous integration. Although if you look at the logo, it says Jenkins guy, but this is not a Jenkins talk, right? I have some case studies and examples that I will use in the talk that was from Jenkins, because it is from like very, very large companies, right? That they need things like Jenkins, but they cannot use things like GitHub Actions. Myself personally, I understand that maybe everybody's maybe using GitHub Actions or Circle CI, and that's fine, right? The examples in this talk, if it's maybe it's a bit Jenkins or not, or it's maybe the programming language that I have examples on, the talk is agnostic, right? It's CI/CD, so whatever your language is, programming languages, it's all good stuff, right? This is a talk of lessons learned. I spent my career, so hold on a sec. So as Paolo just said, I was not sure if the stream was on, but yeah, approximately that time, my family moved, my big family, all the way to Scotland, and my grandfather, my father there, everybody, and I'm the first of my family to come back home. So I'm very, very excited to be here. And after this conference, I will spend some days on the holiday to come and learn about the culture and the history, and I hope I come back. I spoke at TestCon last year. It was the online conference. So here we are. This is my original name, Dragoonis. And they changed spelling when they're moving to Scotland. So, hello. This, in terms of my background and stuff, I'm engineer, running tech companies, up, down, left, right, doing all sorts of dangerous things. I also do open source contributing stuff, PHP language stuff, historically. PHP Fake is the standards body, and of course some things with Jenkins. I'm part of the CD Foundation. CD Foundation is part of the Linux Foundation, and the CNCF, which is the Cloud Native Compute Foundation, is where Kubernetes and things live. So I organize conferences, Scotland PHP. I'm programming many languages. It's just my friend circle and my friends and social. They're all PHP guys when I started, so and yeah, so that's my introduction finished. I've been doing PHP and other programming languages for a long time. Everyone says PHP is dead. It's not. It's just drama and noise. Please ignore that. This is the CD Foundation. As you can see, we have Linux, and the CD Foundation is like a partner with the CNCF. It's all about understanding about CI and CD and giving these projects, the existing projects, continued maintenance and support and funding from the Linux Foundation, like staff and people, and paying them to keep everything moving, and as well as new innovative technologies that are in relation to cloud native, CI or CD, things like that. And so these new projects are also in there. On the CNCF, these are examples. Kubernetes, you should know. There's other tools that I will not. I'm doing CD talks and CI talks. This is a CI talk, so we'll not talk much about continuous delivery. But these two tools here, please, I recommend check them out. Flux and Captain. And the CD Foundation has projects like Jenkins X, which is the cloud native alternative to the classic Jenkins, and Tecton and other things. But despite all of my career, all the things I do, this is how I feel, right? What I realize. And what my message here is, if you do not feel like this, then you're not learning hard enough. You're not learning fast enough, okay? And also, this is what I feel all the time. So if you're feeling like this, don't worry. It's good. You're learning and you're failing, and you're learning and failing. So I used to do consultant, and now I start my own startup 3 years ago in the pandemic because of COVID and stuff, and everybody lose their jobs. Many people lose their jobs, myself also. I was a head of engineering, consultant, and contractors, not employees. I knew it would be okay and fairly easy for me to get another job, but I could not say the same for everybody. So I stopped being consulting and I started a new business, which is basically a tech company that works as a recruitment partner to any business, right? So basically my tech team, we attach to your tech team, and we do all the nasty stuff, the screening, the filtering, interviewing, and the top 2 people out of, say, 100. We drop them into your team, you interview them, bam, the accuracy. So it's basically, we take away all the time-consuming and energy stuff, allowing you to continue to build your products and why you're in the job, right? To build and code, not to be interviewing many people. So that's what I'm doing these days. And if that's interesting, please have a chat. Swiftly onto the talk. The agenda is in 3 sections. Infrastructure, because infrastructure meaning the hardware, right? Like software can run, you can run your test suites and whatever, but ultimately the speed, right, and the feedback cycle you're getting in CI when you're writing your tests or when you run your test against some changes that's the important part, right? You cannot build your house on sand. You have to, if you're doing basic projects, it's not that big a deal, right? But the medium size and the larger it becomes, the more important the underlying details become. So this is what we call a pipeline, right? And the name is in pipe, right? And the grounds is usually straight, but that's not actually real life. This is real life, okay? Obviously, it's kind of a joke, the text, but the point is your pipelines, how you release software or how you do changes and test things, that should be an organic reflection of your organization and the way you are working as humans, yeah? What I am seeing in my career and doing CI/CD consulting for many years is people are trying to move away from older tools to like cloud proprietary, general purpose tooling. And what's happening is that people are having to adapt and change your processes, how you release, when you release, because of the limitations to the cloud tools. It's like YAML file, right? You cannot have much control in a YAML file when you're, right? So that's what I'm seeing. So the point here is you want your pipelines to be ideally an organic reflection of how your business works rather than the business working around the technology, right? Steam wants to do an update. 1 second. Hi, Steam. Yes, please. Boom. So this is a case study example. When I was doing consulting, I was helping the UK government with a large project, and their CI pipelines were taking 1 hour, 20 minutes, right? And so after like 1 week of 2 weeks working on that, I managed to get it down to 13 minutes, right? No loss in quality, no loss in accuracy, just by taking tips and doing stuff and not always clean things, some hacks, some compromises and workarounds. And so these are the things I'm going to show you that can help you in your projects, whether you're writing tests. I just have a question for the audience. Who here is like a tester? Like they're only a tester, not developer? Who here is tester? Good. Okay. Who here is maybe developer instead? Not really much tester? Okay. Okay, got it. So mostly testing, that's good. This is an example of a pipeline that I created. This is a Jenkins pipeline. This is what Jenkins looks like, right? These are all parallel steps, right? And so we have like the beginning, next, but everything is running in parallel. So this was the end result, right? The outcome. So that's the 13 minutes from the 1.5 hour before, right? So infrastructure. These are examples, but it can be transferable to whatever CI technologies you're using, right? For example, Jenkins, you boot it, give it your AWS credentials, and then it just spins up, machines in the background. You do nothing with infrastructure. You don't need to worry. My point here is use spot instances. Lisa? Cool. Use spot instance basically on Amazon or whatever cloud you're using because it's like costs sense, and you're getting your instances. They're called ephemeral machines, which means like temporary machines. They will die very quick. After you finish using them, they will go away. So that is my recommendation. Or you can use like Kubernetes for scaling kind of virtual machines, right, or whatever. So plug these in, and you're good to go. If you're using anyone who is here is maybe still using Jenkins because large. Wow, I was speaking in Germany 2 days ago. I gave this talk in Germany, and it was a lot less, right? The balance was different. So it's kind of interesting to see. So there was actually a lot of people who said, yes, they're still using Jenkins. So my number 1 tip for you, so by default, Jenkins is very good for like survivability, meaning you have the main, the user interface. You have the brain, right? The Jenkins is running, and then you have the workers, right? The workers, and they run your builds, right? The master or the main, by default, is always running in max survivability mode. This is because if there's a network problem, right? Like there's a temporary network lag or the latency issue, the worker will keep running, even if it is not, the master is not knowing to talk, to say, hello, what are you up to? And then the network comes back, right? So it's very durable, right? Very durable. But that comes at a speed cost, right? So by default, Jenkins has to run slower than it could do to make sure that it has it's got ACID compliance, kind of like in databases, right? Like ACID means like atomic, like everything must work. Otherwise, the transaction in the database will not go. It's the same with this stuff. It has to, do that. Anyway, so the tip is, go to your DevOps people, sysadmins, whatever, and say, hey, change the setting to performance optimized. And that's it. Press save, boom, everything goes much, much faster. Like from every button click you're doing, faster to every build that's kicking off. You see? So that is a very quick win. At the infrastructure level, you do no coding, but everything becomes faster. Magic. You do no coding, right? Also, also understanding what the size of the machines or the specifications that you have on the boxes and how that relates to the test suites or the project that has many test suites that you're involved in. So hardware is cheap. Human beings are more expensive than computers, right? So rather than making the humans wait longer for the builds to finish, you just throw more hardware at it, and that is going to be much cheaper for the company. And these are small workers. You have big workers and small workers, and I've explained the differences, right? So especially it's just RAM and CPU, right? And hard drives, I/O speed as well. And doing these things is how you can actually get a lot more faster feedback and speed up everything in your companies without touching any code, right? Yes, there's code changes, but these are things you can do. And in Jenkins and any, say, GitHub Actions that has a YAML file, and stuff, so you can say what you want, right? Obviously, Jenkins is very simple, so that is in your Git repository. That's just the label, and and then Jenkins looks at the label and spins up the machine with the label. Simple. There's something called like executors, right? In CI terminology. It means like on one machine, how many builds can be provisioned, right? If you have one computer and there's 4 people in your team, and then it can run maybe 4 builds, right? But my recommendation is for speed and always for CI. So CI is usually, where a lot of the computation and time and things are running and Docker builds and everything, right? When it comes to CD, continuous delivery, there's not much computation in CPU and RAM happening. It's mostly just waiting for the cloud to do things, wait for Amazon to give you the machines and then it comes back. So there's not much happening on CD. But for CI, my recommendation is throw as much hardware as you can at that, right? And do not be afraid to keep going higher, right? Because especially if it's a spot instance on Amazon, super cheap, right? The point of this slide is set your executors to 1 per worker or 1 per machine. This means that Jenkins, for example, will only ever allocate 1 build to 1 machine. That means you're getting 100% access to that hardware, and there's no other people in your company's builds coming on and taking up that hardware. If you can take advantage of 100% of the hardware, and someone else is coming on, now you're sharing. You have 50%. It is going to take twice as long, right? And so math, it's a simple math. So back to a pipeline. So here is a pipeline, right? In the beginning, we have initialization. Actually, just before that, there is like a checkout, right? Checks out your code. So now everybody that kicks off a build, a pipeline, this is everything. This is your path. So there's 3 parts to this I recommend to take away from here to speed that up. I've joined companies where sometimes it's taking like 2, 3, 4 minutes just to clone the code, right? The Git repo. That's not a good idea. That's not really good, right? And there's a few reasons that happens. So number 1, shallow clone, right? Shallow clone and shallow clone depth, meaning that 2 parts. First one is when you're on your local computers, you clone the code, but you're also So git clone gives you all the branches, yes? So you can switch between your branches in Git. That's normal. But in CI, it does not care about that. It's building, feature 1 branch. It does not care about 2, 3, 4, 5. But by default, all the CI systems are configured. You will clone all the branches, even if you're only using one. And it takes a long time. And the longer, because Git has history, the longer your projects are going, the slower and slower it becomes. And the bigger problem it becomes just to get that feedback cycle. For example, let's say you forget a semicolon at the end of your line on your code. Oops, but you don't know because you're waiting a long time for the feedback cycle. Oh, I forgot a comma or something silly, right? Syntax error. So you want to get to that point to realize. So that's shallow cloning is, well, conceptually meaning that you only limit the CI to check out your branch only. And each branch has a history, right? In Git, when we push or changes, history. But the CI does not care about 5, 10 commits, ago. It only cares about the latest code at the latest commit. So what you're saying is to the CI is like, give me one branch and the latest commit at that branch, and I don't want anything else. That's way, way faster, right? And by doing that, every single build will just speed up, right? Regardless of the test suites. The second part is fetch tags, okay? So in Git, when you're making a release, you'll tag your code, like version 1.1, 1.2, version 2.0, and then you release, right? Or whatever. So by default, tags are very slow. And by default, when you do git clone or git checkout or whatever, it will pull the tags also. Now, tags are only important if you're making a release, if you merge into the main or master branch, right? But if you're on a feature branch, you're not making tags, but it's super slow. And the more releases you do over time, the more tags there are, the slower it becomes. The problem just gets worse and worse. So by default, if you type git clone -- no tags, boom, you get the code, no tags, right? I do not know why the tags are slow. All I know is they are very slow. I did not look inside, I just turn it off. And that, if you turn off tagging and these, your code will check out in almost instantaneously rather than waiting time, right? This is an example of, so I use Jenkins example because Jenkins is quite clean and small, whereas like I cannot fit a YAML file on a slide for you, right? Because the YAML files are like this size, okay? So again, everything here is conceptually transferable to any tech you're using. So if I have this in my repo, then I get, it knows to give me a big machine. This is a CI and stage, and then inside that you have like parallel stages. You will see it visually. So that was checking out code. Next is on-off switches, right? So these is like temporary hacks, workarounds for you to get you doing what you're doing. The most people in the audience are testers, right? So there's testers changes and there's developer changes, right? So for example, if you're making changes to a test suite, let's say it's something later, like a user interface or API tests, not something smaller like, more internal functional tests, right? So let's say you change user interface tests, right? Cypress or Selenium or whatever you're doing. But you have to wait for the unit tests and the functional tests and integration tests to finish and complete before it will run your tests at the end, right? The user interface tests at the end. But if you only change code for the user interface tests, why are you waiting for everything else to complete first, right? So if you think about it, if you write code and you architect your test frameworks or your test suites, we can also architect your pipelines, right? In the same way of thinking, if you think in advance. So here is a pipeline. It has many steps. Let's say you, for example, you're changing this guy here at the bottom, yeah? So why are you doing not run all these, right? But most of the way that these things are working, you have to wait, and time is money. So this is at the top of a Jenkins file. It is just a variable, Boolean, true, false. By default, everything is true because everything is on. But when you make a feature branch, in your branch, you can just set these to false, and it will not run. That's time, that's speed. So you're not changing it. You're not doing any mad, crazy things, right? Every like YAML file or Jenkins file has a when, like do this when true or false. So here is just saying when the variable, the global variable, like these global variables, when this one is true, then run it. So if you turn it to false, it won't run, obviously, right? Now, another point here is be careful if you try this. Because, of course, we are humans. We forget, we make mistakes. So on your branch, maybe you're turning things off because you don't care about those things, nothing's changed, and you merge the code. And then on the main branch for production, it forgets to run the test suites. There is bugs, of course. Boom, big problems, okay? So my tip here is get the function I wrote is get branch name, and if it's master or main, and what this means is defensive programming, right? So if somebody forgets to turn this variable to true back on before you merge, it's safe because it's an or condition, right, in the middle. And yeah, basically, that makes sense, right? So it doesn't matter if you turn it off. If it's on the main branch, it's going to run it every time. Who cares? And that's a tip that we learned the hard way. This is the initialization step of the pipeline. You're not running anything serious yet. My tip here is refresh the state of the Git code at the beginning of the pipeline. Do not clean up at the end. We are, technical people, engineers. We like to be clean and organized, right? So like you do stuff on a computer that runs less things, and then you clean up at the end, okay? That is very common practice. Do not do that, okay? The reason you do not want to do that is if there is a bug and it's on CI, and you want to go onto the machine to inspect and understand why there's a problem, you cannot, because like a mystery murder, the murder just disappears, right? There's bugs you don't know because the code is wiping itself. So I'm saying leave the hard drive intact. Do not clean up anything at the end. When the next build is coming, then it will clean and just reset. And this example of a git command we use to basically just reset the code to clean, right, from the previous run. And that's all it is. So again, do not clean at the end, at the beginning. This is the next stage. It's called linting, right? Linting tests. Linting is the most underappreciated and undervalued part of testing, quality checking stuff, right? Because it's instantaneous. You're not running any tests. It's just checking the syntax, semicolons, brackets, braces, right? Basic things. So my advice is invest in linting as much as you can because it will take milliseconds and not minutes in comparison for the feedback cycle to happen. Hope you can read everything. The top one is called shell check. It's for bash scripts. Bash is not very easy. You can always see there's problems. So throw shell check at all your bash files, right? And if you have a problem, you'll know about it there, right? The next one is bash unit. So bash unit is inspired by PHP unit, and PHP unit is inspired by JUnit, right, in Java. So this is only 1 month old. My friends created this, right, recently. You can lint your Docker Compose files. You can lint Docker files. So think about it. If you rather than running Docker build or something and it fails, obviously because you forget a bracket or something, just lint it. You'll know much quicker. All right. This is bash unit. It's an assertion library for bash scripts. 1 line, install it. This here is basically an installer thing, and it runs a command, install sh, and then you've got these on the left side, you've got these assertions that, do things and you pass it. Here is an example. So on the left, you can say, you run a command in Linux, you get all the output. That output is in a variable. If you look on the slide, it says output equals here. So it's in the variable, and then, you're using it, right, later. Also, here, look, installer at the bottom. So you're saying if there's a file exists or directory exists or something. So on the right-hand side, we're always doing these things by ourselves, right, in bash, if we have to, or someone is doing, your company is doing that. In remembering the syntax for bash, like to check, is it a directory, is it a file? It's time-consuming and buggy. So you could just give it the name of the directory, and it will do stuff. So if you run, let's say you run a test suite, right, and that test suite has a report, right? You're generating a report for your tests, nice fee for the business, right? Well, you want to check, is the file there? Did it create the output directory for the report? Is the file there? Is it readable? Is it writable, right? So immediately after you're running, I have a question. What kind of programming languages are you using? Is it, say, JavaScript? JavaScript people? Okay, done. What about Java? Okay, you're Java people. Okay, well, not all of it, but many. Okay, so, yeah. After you run your Java test suite, after that, do some assertions, just to make sure that your test code did the things you did it. And it's a very lightweight and easy way. Quick wins, right? That's it, that's the URL, right? The slides will be up later so you can see it, but there you are, all right? Keep moving. Let's move on to Docker stuff, right? So this tip is here, it's called working ahead of yourself. This took me a while to learn. As technical people and engineers, we like to be clean and organized. Like, okay, we do the Docker builds, and then we do all the unit tests for all the project, and then we do all the functional tests, and then the user interface tests, right? And that's normal. And what I learned is that there is a lag between the steps, the phases of your pipelines, because let's say you need a database for your MySQL, you need a cache, maybe you need a queuing system like RabbitMQ or something. You need some things. You need to spin them up. You need to put SQL into the database to prepare for your tests to run, right? So that takes time. But if you wait until it is starting that part of the pipeline for the functional tests or integration tests, it cannot run your tests because it has to go to the internet, pull down the images, Docker pull, right? It will pull MySQL images or do stuff. So it's doing nothing. Just waiting for computers to talk to, send data, right? So here is, hold on. So my point here, the point is in like 3 slides, okay? So basically the first point is you're going to be doing things under the hood, Docker pull, right? So this is just the build part, right? We're just building stuff. We're not running any tests, but the Docker build is quite slow. It can be maybe 1 minute, 2 minutes, 3 minutes, right? So Docker build and then run tests. Or do Docker build and in parallel pull the images that you're going to need for when the tests are running after. And therefore, as soon as the Docker build is finished and you go to start executing your test suites, there's no lag and it goes boom. And it's instantaneous, no delays, right? And that's something I didn't learn for a while and so to share with you. Also example, this is example of many people's pipelines, YAML, GitHub Actions, files. Don't do this. Don't do this. This is GitHub Actions. Don't do things like this, okay? Do things like this, okay? So simple things, but there's good reasons, right? This is PHP run JUnits, run Cypress, whatever, right? The point is, this is not repeatable. If there is an error, failure on the line 3 or 4, how do you debug that? How do you repeat that? Change some code and rerun it. How do you do it? Well, people are just copying and pasting things from the YAML file onto the shell to try to figure it out, right? For your tests, right? You cannot do it, and it's not a good idea. But you can do this. You can run that, yeah? So the same code that the CI system is running, the same shell script, or whatever script is the same as you run. You can also run it on your local machines. So when I'm trying to debug things, failing tests on the CI, you can just run the same thing on the local. The only difference will be the environment variables, the secrets and the passwords, maybe for, sensitive systems, but on the local, you're using basic stuff. So this is the start of just making small changes, but they're going to make things like debugging, which is the hardest part, right? Debugging is very time consuming, so it makes it easy. And this is architecture, right? So the steps it's what the CI system is executing, right? You have a VM or whatever, so it will run, check out the code, do the Docker build, and then you can tell it to run your step, which inside it just runs Docker run, right? For example, test scripts at the bottom there inside your containers, inside the projects, right, that you have. And this will make sense. So this is what really good looks like, because you get a lot of value after you do this. So if you're on the host and you run PHP Stan or run Cypress or run your JUnit or whatever, this is a very basic example, but what you're doing is you're doing Docker run, and then it's the same Docker image, right? Phoenix is the name of the project, so whatever your project name is. So you build your Docker image once for the application and for your tests, and then you just repurpose it. But every time you're running that, you're overriding the entry point. By default, the Docker container for your application will be like Apache or Nginx or something, right? And that's when it's running in production. But you want to do is keep the same environment and just override the entry point every time. Now you can do it in parallel because you can have 5 Docker images become container, boots up, but the test suite you're running, right? API test, UI test, you see? So they're isolated now, but it's very easy to just change that. So this script is inside the container, yeah? And the file we're running is on the outside. And that is what I mean with this stuff, okay? So, run unit tests, run integration tests, run acceptance tests, yeah? And these are just the real commands. The reason you're going to get value from this is because now you are taking over the process, not the CI. Because on your local machine, or if you go into the CI box, if you're debugging, you can then just run acceptance, run unit. That's it. And whatever the CI is running, you're running. It's identical. And therefore, you can bring all your CI problems from the cloud to your local machine. But it thinks you're CI, you see? So you get a lot of value in that, and it helps. So this is just an example of inside. This could be like JUnit run, right? So that's inside scripts. Moving on. What does it say? Okay, so when you're doing Docker builds, do them in parallel. That's it. I see many people doing Docker build 1, Docker build 2, Docker build 3. Even if it's not for your pipelines for running your test suites, but perhaps it's developers in your teams. Maybe you cannot run your tests because you're waiting for the developer changes or the application to finish creating an image before you can run tests against that thing. So you're kind of blocked on your work as testers because you're waiting for developers' things to be ready. So these are also tips that you can take back to your development team or your DevOps team, whatever, to say, hey, if we did more things like this, I think my job as a tester, my feedback cycle would be much quicker, okay? So Docker build in parallel. Inside your Docker files, who here is familiar with what a Docker file looks like on the inside? Okay, 60%, that's cool. By default, most people are just, this is what clean looks like in the Docker file. Most people, they're doing like the bash, what I've seen before, like all the crazy bash, right? You cannot debug it, cannot repeat it, cannot build it easy. So what I'm saying is, take all the nasty, make a script, and inside your Docker images, do, install your relic extension, the agent, or whatever, right? So that's what clean looks like. You can repeat this. So if you have a bug on the Docker build stage, you can then, go into the container and just run make a change, run this shell script. Otherwise, you're running like, say, 5, 6, 10 commands over and over just to get the thing right. So clean. This here is an example of you do something in a Docker file, the first line. You do something second, right? Check what happens in your Docker files when you're building them, because there will be problems and you cannot catch them, right? This is kind of assertions, right? As testers, you know what assertions are. So you use like assertion mode for your Docker files. So basically, this is basically saying, do a thing and make sure the pcov thing, which is PHP coverage, code coverage for the tests. Make sure I check it's there. I make sure it is there, it's installed. So that tells me the previous command and the file that it depends from configuration is all working, right? And then grep, I need to make sure that the string is disabled, because you do not want to ship your things to production, things that should not be on there, like debuggers, profilers, right? But they're useful. You want them in your applications or the test applications. So this is, again, more defensive programming, right? It will always, by default, should be disabled by default, so that when it builds and goes to production, you're safe. And then, of course, on your local environment, inside this file, you will do the 0 to 1 or off to on, and you can use stuff temporarily, but it's defensive. So when you go to cloud, so that again, shiny things, do assertions, and check that things are off. That should be off. I'm sure in your mind, if you think, oh, are the things we're installing that we use good for local but should never be production? Yes, okay. How do I make sure they're always off, right? And that's the tip, okay? And then enable things on the fly. And PHP takes its inspiration from Java. They're called directives. So PHP-D, this is Java stuff, the same convention. And when I execute PHP to run, say, my test suite down here, right, or run JUnit here or whatever, just turn the thing that is off by default, I can turn it on the fly just for this run. You see? So it's off by default, turn things on, and you get good stuff. And that's a good technique to use. Next, we're using security stuff, right? let's say you're using JavaScript and you have the public node JavaScript packages, npm.org and stuff, right? You have the packages, but you also have custom packages in your businesses, right? Custom repositories that when you do npm install or pep install, whatever, you will get your custom packages from the custom repositories. So you'll need credentials for that. Many people do make mistakes or accidents where there's credentials lying around because CI needs the files, CI needs access, but somehow it's in there. My point is, in Docker, even if you try to delete if you copy some credentials into the container and in the build file and it runs, then you will lose. And then later you try to delete the credentials, they're not going away because Docker has layers and it caches them. Yeah. So in a later step, if you delete something sensitive, it's not gone, it's still there. If you type Docker history in the name of the image, you will see all the layers. And so that's how you get hacked, right? So just my point is, there is a secure ways to do this in Docker. Docker has a new thing called BuildKit, which is the engine. Docker is now a label. It's an implementer of BuildKit. There's other implementers of BuildKit. And it has new shiny things that when you install Docker by default on every computer, it has BuildKit, okay? So by default, it is always on, but this slide I made before it was like the canary or the experimental. So environment variable, you can turn it on and then run Docker build. But now you don't need that because it's now 2023, not 2022. So here there is just credential files and it's a special secret. Here is cool. Also SSH default. So the SSH key that you have on your machine or any machine to like check out code, it will securely and temporarily put your credentials into the container and then it will do stuff, but then it will get an array before it makes the layers and before it captures and keeps and so you don't get hacked basically, right? So that's anyway, point is, cool things here, do secure stuff, and it's easy, right? Prep for the integration tests. So this is unit tests part, I'm doing prep. Never mind, moving on. So if you're running integration tests, right, or functional tests, you need databases and extra things. So this is an example of what good looks like, or clean, is Docker Compose. Who here is familiar with Docker Compose YAML files? Okay, cool, half, 50%. Anyway, you write this stuff, you get these guys, they come up. But this up here at the top says API tests. So this is not like Docker Compose YAML, this is Docker Compose.ci.yaml, right? So you have a different YAML file for your application versus your tests for CI systems. So at the top, it says API tests, not app, right? And in that, it says entry point also. Remember before I showed you an example we were changing the entry point on the command every time? Well, that's bash, it's so clean. So YAML, same thing, but different way. But now you get all these guys, right? All the extra things. Now, when you do Docker Compose run, and then at the end you see API test, and then at the bottom, look, it says UI test, okay? Now, as you know, if you have test suites and you're talking to database, and you try to run the test in parallel, things break, right? Because test 1 changing data, test 2 changing data, they are conflicting and bad, right? And then it has problems, okay? So without changing, because you want to scale in parallel, you wanted to run multiple test suites at one time. But if you're just having the one file, then every test suite, like API, UI, will all be hitting the same database, right? And it will not work. So this is the magic. It says -p. -p must have a project, right? If you're on your computers using Docker Compose and you see containers with like default underscore, yeah? Default underscore, that's actually because you did not give it a project name. So that's why you're seeing default underscore, right? But what you do with -p is it creates an isolated copy of everything. So whatever this is, API test has its own database, its own cache. And so you don't change any YAML, you don't change much, you just do -p, isolate, and therefore you can parallelize it, and it's fast. You see? I hope that makes sense. I recommend checking up. How are we for time? Hello?
We're going to have time for one question only.
Well, sure. I'm just meaning a slides.
Hello.
Slides time. How long do we have left? How long for slides? Just like
30 seconds.
Okay. Thank you. I'm going to skip to the last part. You can watch your UI tests in CI, right, with a VNC. So if you have Selenium or something, there's Selenium debug version, it's a VNC on your machines, you can actually watch what's happening on the cloud in the CI. And you can interact with the browser and see stuff, so that's a tip. Yeah. Last slide then. I was trying to, I don't have as much time as I want, but basically get ready for the future of CI/CD. This is Dagger, okay? Dagger is created by the creator of Docker. So creator of Docker has now created a new thing. It's very aligned with what I'm helping. So 2 weeks ago, I contacted Solomon and his team at the Dagger team. And for the past few weeks, we've been building exciting things. And I will leave it at that. I was so inspired and so excited about this project that I spent like 10 hours coding on the first day. And I sent this to the Dagger team. So not much time to talk about Dagger, but it is, remember before we had Docker? Like before we had Docker, we were just running virtual machines, yeah, and Vagrant up and doing things. Now we don't do that, we just have a container, yeah? That was revolutionary, right? And my point here is Dagger is revolutionary to CI stuff, okay? So I recommend you check that out. That's us for time. Thank you for your listening. And we'll publish the slides online later to see it more, okay? Thank you for your time.
Thank you.